Hello, algebra students. Mr. Lawrence here, and today we're going to be graphing a slightly different type of linear function. It's actually not a linear function, but it's similar to it. It's going to be graphing absolute value functions, and I thought I'd written the name down. Perhaps it's up here. Yeah, graphing absolute value functions. So y equals absolute value of x. Now you know y equals x would just be a plain old line, right? And it would have a slope of 1 over 1, and it would have a y-intercept of the origin of 0, 0, right? And it would just go forever like this. Wonder what's going to happen when we put an absolute value there. An absolute value around the x. Well, let's first stop and think. See if we can make a prediction before we actually find out what's going to happen. Remember, the definition of absolute value is the distance from 0 on a number line. And so if I think about this as an input-output table, I've got x, and then I'm going to have the absolute value of x, which is the same as y. Instead of putting y there, I put the absolute value of x. And I want to know how far, how many spaces, how many units certain numbers are from 0 on a number line. Well, if I'm at x equals 0 right here at the origin, then I'm 0 spaces away, right? And if x is 1, well, let's see, I'm 1 space away, so I get a point right there, don't I? And if x is 2, then I'm 2 spaces away from 0 on a number line. So right there. And then, of course, 3, 4, 5, etc. Well, what happens when I get smaller than 0, the numbers that are smaller than 0? Like if I put -1 in. Well, -1 is 1 space away from 0 on a number line. All right, so when x is -1, y is +1. When x is -2, well, the absolute value of -2 is 2. So it's going to do that. So what's going to happen is we're not going to have this part of the line here. Instead, it's going to be bent or broken up into this direction like so. Okay, and of course there should be an arrowhead on there. So it's going to look something like that, right? Oh, that's pretty cool if you think about it. Yeah, it just takes that line and makes a bend or a break. Now the key in doing this is going to be finding the vertex, okay? Y equals absolute value of x. It was really easy to see the vertex, but we're going to try some different equations, and I think I'm going to do this all in the graphing calculator so that you can figure out where the vertex is. So let's get my graphing calculator up here. Where'd you go? There you are. Okay, and let's just type in the simple y equals the absolute value of x. Now to find, if you want to do this with me on your graphing calculator, you press math, and we want to go to number. So I'm going to arrow over to number. Notice number 1 is ABS, that's absolute value. You have a choice. You can hit the 1 or you can hit enter. The absolute value of what? Well, let's just do the absolute value of x. Okay, and then I'm going to graph it. And sure enough, there's that v that I expected, right? Okay, now, what do you think will happen if I have an absolute value of x? So I go to math, I go to number, hit the 1, absolute value of x. And let's add 3 outside, okay? What do you think will happen to my v? Go ahead and make a prediction. The v is going to be altered some way, right? Because it's not just the absolute value of x. I'm adding 3 to it every single time, whatever the absolute value of x is. I think, hopefully you've made your prediction by now, I think the v is going to shift up 3 units. Because if I did the absolute value of 0, I would get 0. But then I would add 3 to it, so it would move up to 3. I think that's going to happen every single time. So let's go with that and see what happens. Ooh, and look at that. It did shift up 3. I get the same v, only it's 3 units higher. Now, by the way, if I hit my trace button, okay, there, you see I'm at the origin of the blue equation. And there, if I shift up, I'm at 0, 3. Okay, so it seems that when something is added to the absolute value, it shifted it up. Do you think the same would be true like if I subtracted something? Let's test it. Let's test it. So let's put a minus. Yeah, we can keep 3 there. Let's go -2, just to be different. All right, so we'll hit graph. There's the original, okay, the blue one. And here comes the red one, and sure enough, it shifted down. So if I have something added or subtracted to my absolute value of x, that shifts it in the y direction. Yeah, the y direction, okay? All right, let's go ahead. I'm going to get rid of that one temporarily. And let's see what happens if I add something inside the absolute value. So math, number 1, there's the absolute value. I need to put x in, and let's add 3 to it. Okay, now before we hit graph, let's see what's going to happen. All right, or let's make a prediction of what's going to happen. Well, remember, when something was added outside the absolute value, it shifted the whole v up. If something is added inside the absolute value, do you think it'll shift it like maybe to the right? What do you think? Make a prediction. And then let's see what happens. All right, here we go. I'm going to hit graph. Going to see what happens. Okay, here comes the original blue one. And there, wait a minute, look at that. It didn't shift right. Even though it was +3, it shifted left. Yeah, that's pretty cool. Why do you suppose that happened? Look, there I'm at the vertex of the original. It's at 0, 0. But when I'm on the red one, let me plug in. Looks like it's at -3, the vertex. -3, 0. So when it was x plus 3 inside the absolute value of x plus 3, it shifted my whole v left. You know, we should make some notes about this. So if we have an equation, well, let me start with this. Y equals the absolute value of x, and then I'm going to go like this. I'm going to go +3, and I'll go in blue here. Let's go +2. Okay, this shifts the vertex. What's the vertex? It's the bottom of the V, the vertex, to -2 in the, how about 2 to the left? That might be, sorry, 2 spaces left. Okay, the red one, since it's +3, what is that symbol there? Okay, it's +3. That's going to shift 3 units up. I would definitely get this in your notes, okay? What do you suppose will happen if I had this? Y equals the absolute value of x -4 -7. What would happen then? Well, this, I'm guessing, should shift it. Well, maybe we better go and check. Hold on, let's not give the answer yet. Let's go and explore. So we got -4 inside and -7. Okay, let me get rid of, well, I don't have to get rid of the whole thing, but I can edit it. And so let me go -4 and -7. All right, so what's going to happen when I do this? Well, this, I think, is going to move it down 7, the vertex, right? And this, if adding moved it to the left, maybe this will move it to the right. So the vertex will move right 4 and down 7. That's my prediction. Let's see. Here comes the original. Yep, the y equals absolute value of x. Now here comes this one. Ooh, look at that. Did it move? Let's see. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7. Yeah, I think I was right. If I hit trace, okay, and I'll drop down to that one. Now I think the x-coordinate is positive 4 there. And yep, it shifted the vertex to 4, negative 7. Do you see how you can tell the vertex simply? I mean, the vertex will be 4, and then negative 7. So you see how what's happening here? The x-coordinate, you take what makes that 0. And the y-coordinate of the vertex is just this number, kind of like a y-intercept. Yeah. Well, tell you what, make a prediction on this. Let's make one up. Let's see. Let's have y equals the absolute value of x. I don't know. Let's go with plus 6. And then let's go with plus 2. I think my vertex should be at the point, the vertex should be at the point of negative 6, positive 2. That's what I guess my vertex will be. I look at this equation, I see it looks kind of like mx plus b. It kind of does, where like out here there would be a 1, right, in front of the absolute value. That's like an m spot. Okay, so let's see first of all if I'm right, and I've got another question for you, but I got plus 6 plus 2. So let me see here. Get rid of this. X plus 6, and then plus 2. And so we're going to graph. There's that. Oh, did I get it at negative 6, positive 2? Is that what I predicted? It is. So let's see if I did it right. Oops. I want to hit trace. I want to make sure I'm on the red graph. And I think the x-coordinate is negative 6. And sure enough, negative 6, 2, there's my vertex. Now, I wonder if it's possible to not have a slope of 1. Like, what might happen if I took y equals the absolute value of x? But instead of having just the absolute value of x, what would happen if I put a 2 there? I wonder what would happen. Well, let's find out. Let's go to our graph. And let me get rid of that second equation. Okay. And now I want 2 times the absolute value of x. Okay. There we go. Got the equation I wanted. And I'm going to hit graph. Here comes the original. Now, the vertex should be in the same position, I think. Ooh, look at the red one. It got narrower, didn't it? Of course it did, because I'm rising 2 and running 1. I'm rising 2 and running 1. I'm rising more than I'm running. What do you think will happen if I made that, say, 4? That you get even narrower still, because now I'm going to rise 4 and then run only 1. Let's see. Here comes the original. And now we're going to, look at that. Look at how skinny that is, how narrow. It's from the vertex. We're going to go up 1, 2, 3, 4, and over 1. And then 1, 2, 3, 4, and over 1. Yep, it's doing it in both directions. It's kind of weird because you have to go over in both directions. You know, it's not just a straight slope where you go positive 1. It's like the run number. You have to do it with a positive run number, and you have to do it with a negative run number. What do you suppose would happen if I change that 4 to a fraction? Let me parentheses, and let me go with, say, I don't know, let's go with 2/5. 2 divided by 5. All right, and then I need the absolute value of x. And so if this is the slope, if I'm right, I should rise 2 and then run 5 in both directions. So this thing should get really wide. Let's see. Ooh, look, it just showed up on that little one. I don't know if you can tell. Here comes the blue one. The original, y equals absolute value of x. Bam, look at that. Yeah, because I'm rising 2 and running 5. So the V is opening up almost like a book. So, well, we better like put all this down here. So we've got kind of y equals m, absolute value of x, plus h, plus k. Okay, now the vertex is at negative h, k, right? Because we took the opposite sign here, and we took the actual number there, okay? The m is like the slope, but there's really, you have to do two slopes. You have to do the rise over the run, and then you also have to do the rise over the negative run. The negative of the run, you have to do both. Okay, so what would happen, what do you suppose would happen if we had y equals, let's say, 1/2 the absolute value of x minus 3 minus, I don't know, 6. Well, I think my vertex, see, my vertex is in green here, I think. Vertex is going to occur at the point 3, negative 6. Okay, so the vertex is going to happen at 3, negative 6. Okay, now the slope, there's going to be 2. It's going to be 2 slopes. It's going to be 1 over 2 and 1 over negative 2. I wonder if I can make this graph and then compare it on the number or on the graphing calculator. See if I get the same thing. So let me get a sheet of graph paper out here. Okay. So I think my vertex is at 3, negative 6. So let me go 1, 2, 3, and then 1, 2, 3, 4, 5, 6. 3, negative 6 right there. Then I think I'm going to rise 1, run 2, rise 1, run 2, rise 1, run 2. And so I'm going to have a ray coming off of there, kind of like that. Okay? But I have to use the other slope, and the other slope is going to be rise 1, run negative 2, rise 1, run negative 2, rise 1, run negative 2, and this should be a ray going off like that. So if I'm correct about all of this, that's what it should look like. It looks like it's at 3, negative 6. So let's go to the graphing calculator. And what was it? Okay, so my equation. Let's see, I want to change that 2/5 to a 1/2. I'm just going to edit it. Now, inside the absolute value, I want minus 3. And then what did I say? Plus 6, I believe? Plus 6. No, minus 6. Minus 6. All right, let me make sure. Got it right. Let's see the original equation. 1/2 times the absolute value of x minus 3 minus 6. Okay. 1/2 times the absolute x minus 3 minus 6. All right, let's see what it looks like. Let's graph it. Here comes the blue one. And the red one is looking a lot like the one I just did. Let's just check it. I think y is going to be, or x is going to be 3 when y is negative 6. Yep, there's my vertex, 3, negative 6. Now, I rose 1 and ran 2. So what would happen if I put x for 5? Yep, there we go. We rose 1 and ran 2. And it would also work if I made x 1. I should also get negative 5 because of symmetry. Yeah, there you go. Pretty easy stuff. So, to graph an absolute value function, let's go y equals m times absolute value of x minus h, plus h, right? Plus k. Okay, so to graph an absolute value function, step 1, find the vertex. And the vertex is the negative of h and the actual value of k. So you change the sign here, and you keep the sign there. Okay, then step 2, find 2 slopes. The first slope is rise over run. The second slope is rise over negative run, and now you have it. Okay, we're going to have a little video quiz here. I need you to do 2 graphs. The first one will be y equals the absolute value of x, minus 3, minus 1. I want to see you make a graph of that. Okay, this is the video quiz, by the way. Okay, and then the second equation, second one is going to be y equals negative, let's not go that yet. Let's go with 3 times the quantity, times the absolute value of x plus 2, x plus 2, and then let's go with plus 4. All right, so that's your video quiz. See what you can do with it. Mr. Lawrence signing off. Have a good night, everybody.